So in the last video, I showed you guys how to solve a homogeneous equation with an integrating factor. Now in this video, I'm going to show you how to solve a differential equation that is non-homogeneous, meaning the equation is not set equal to zero. You have a non-zero answer. So like I showed in the last video, the first thing you want to do is get it in the standard form of a first order differential equation, which is y prime plus some function p of x times y equal to some other function of x. We can call it q of x. So the goal is to isolate the derivative, your first term, the y prime, and get it into this equation, this form, because you want your integrating factor you can only find the integrating factor whenever it's in this form. Your integrating factor is whatever p of x is. Whatever the function of x multiplied by y is your integrating factor. You can't leave it like this and get your integrating factor. You have to get it in this form. You have to isolate the derivative. Now, to isolate this, what we would do is divide both sides by x. So, dividing by x, that's basic algebra. We just get y prime plus 2 over x y times y is equal to, and 8x squared divided by x is just 8x. Now, whenever I took this course, whenever I would get my differential equation into the standard form, I had a habit of, and I think it's a good habit to have, I would always put my p of x in parentheses and get it away from the y. We also got to remember that an integrating factor, which I also talked about in the last video, I call it I of x. And it's equal to e raised to the integral p of x dx. So now that we have our differential equation in standard form, we want to find our integrating factor. It's going to be e raised to the integral of our function p of x is equal to 2 over x. I'm going to write that over here. So that's our integrating factor. And the integral of 2 over x is just 2 ln x. So we get that's equal to e raised to the 2 ln x. And in the last video, I told you how natural logs and e, when e is raised to a natural log, it's going to cancel. And whatever coefficient you have in front of the natural log is going to become the exponent of whatever is inside the natural log. So just do this. So this, our integrating factor, I of x, is equal to e to the 2 ln x. The ln and the e cancel, so we're left with x. The coefficient becomes the exponent, which is x squared. Now, here's where things become different from the non-homogeneous equations. Whenever you have, oh my god, this is where things become different from the homogeneous equations. Whenever you have a non-homogeneous equation, you need to set the derivative of y multiplied by the integrating factor. So we take y times x squared and we set that equal to q of x times the integrating factor, which is right here. 8x times x squared just becomes x to the third. 8x to the third, I should say. And let me write the form for that, actually. Let me see if I can write that down here. So after you get your integrating factor, the form you want to get your equation in is going to be exactly that. The derivative, d over dx of y times your integrating factor, I of x, is equal to q of x times I of x. Now, we can also say that this is equal to this other form. You need to know both of these forms for non-homogeneous equations. Y times I of x is equal to the integral of q of x times I of x dx. You need to know this form, or these forms, to solve non-homogeneous equations, and that's where the difference comes in from homogeneous versus non-homogeneous. Because with the homogeneous equations, anything times 0 is just going to be 0, so you don't need to worry about that. But you get a little more integration with the non-homogeneous equations. So we have this in this form here. So we want to get it in this form. So y x squared is equal to the integral of 8x to the third. And the integral of 8x to the third is just 2x to the fourth. Oh, and we got to do plus c. Yeah, plus c, our constant of integration. You can't forget that because we took the antiderivative. Now we want to isolate y to find our general solution to this equation. To isolate y, we just divide both sides by, it's supposed to be a 2, x to the second. So our general solution to this differential equation, it's one of the form y is equal to 2x squared plus c over x squared. And that's how you solve a non-homogeneous differential equation of the first order.